Diese Konferenz wird nun aufgezeichnet.
Welcome to the third Dresden Nexus Conference 2020, this year in a virtual format. I'm Christina Dornack and I'm Professor and Director of the Institute of Waste Management and Circular Economy at Technische Universität Dresden. The Dresden Nexus Conference 2020 is held under the topic Circular Economy in a Sustainable Society. The aim of the conference is to discuss scientific questions on the individual topics of the conference, such as how can the transition to a circular economy be accelerated, and how is the circular economy subsequently implemented in daily life. Uniform international standards on global level and instruments for local implementation of the principle of circular economy should be established both regionally and sector-specifically, primarily through knowledge transfer and exchange of experience. One focus is the resource perspective of circular economy. The resolve principle, regenerate, share, optimize, virtualize, and exchange, has established itself from this resource perspective in the last years. In order to implement this principle, we want to discuss how, for example, through incentive systems and education, the circular economy can be implemented more strongly and more broadly than before, because circular economy is without an alternative. We engineers can only follow this path together with natural scientists, together with economists, with social scientists, and also with politicians. We still have to learn, and we will have to accept setbacks. The development of new products actually does not always include the idea of sustainable circular economy. Economic interests, the desire of convenience and sustainability, social justice, technical possibilities and ecological sense must be harmonized. I would like to address the technical aspect of circular economy and look at closing the loop from a waste management perspective. Our aim is to reduce the amount of unavoidable waste significantly. Unavoidable and non-recyclable waste must be minimized. However, pollutants must be removed from the cycle in such a way that they do not represent a burden for future generations. This ultimately leads to an intensification of resource use and an increase of resource efficiency. The presentation is entitled with the engineer as a pragmatist or an innovator. The engineer is in the tension field of legal requirements, of environmental requirements, of economical requirements, and of governance. For the technical requirements, we are mainly responsible from the waste management point of view and from the construction point of view, but we also have to consider the social characteristics and to include the politics. In this field of tension, we are active and we have to handle and find a good solution for circular economy. What is the social challenge we have to do? When we look at the world's map of the mega cities or of the big cities, we see that in 1950, approximately 220 million people lived in cities. That means 13% of the world's population, and the daily amount of waste they produced was almost 300 tons. 5 years ago, in 2015, 2.9 billion people lived in cities. That had been approximately 50% of the world's population, and the daily amount of waste they produced was more than 3 million tons. And let's have a look into the future. When we have a look to the mega cities in 2030, we see that approximately 70 to 80% of the world's population is expected to live in cities and produce 6 million tons of waste every day. We have to consider that the waste management for these cities is a special challenge because it's a huge amount of waste and we have less space than in rural areas. That is the challenge for the future with the megacities. And when we have a look to the international challenge, what we have, then we see that we start in different countries with different situations regarding the income and the waste amount. You find some examples for food consumption, and in Germany, every family has $225 per week available for food consumption. And you see a normal German family has about 4 persons. When we have a look to Ecuador, they have available $31 per week per family, but the families are much bigger, that are 8, 9, 10 persons in one family. And let's have a look to a very poor country like Chad. They only have $1.26 per week per family. And we see that the food, the packaging of the food is very much different, and as well the waste is very much different. The challenge is the consumption increases with greater wealth. The amount of undegradable packaging waste increases with a larger consumption. More packaging means higher demand on resources, actually on primary resources, and at the same time a higher volume of waste. When we have a look to the economic challenge, we see that in developing countries, a proportional relationship can be made between an increasing gross domestic product, the GDP, of the state and an increasing volume of waste. In industrialized countries, on the other hand, there's a tendency to decouple these two variables. This is achieved by increasingly efficient production methods for products and their packaging and increased waste avoidance. We see here the annual gross domestic product of the prospective or of representative countries in 2007 compared to the specific municipal solid waste volume. It's more or less a linear relationship with the words I told you regarding the decoupling of waste amount and GDP in the industrialized countries. There are lots of framework directives in the different countries and all over the world. The EU established the Waste Framework Directive in 2008, and the most favored option is the prevention of waste. If we have waste, and we have a lot of waste, we have seen, we prioritize the preparation for recycling, the recycling procedure, and if recycling is not possible or not economically sensible, then the recovery and production of energy from this waste is favored. The least favored option is the disposal of waste. And all the European countries had to bring it in the national legislation in the last years and to follow these regulations. But what is the situation actually worldwide? We have here 2 pictures from a landfill in Vientiane in Laos we visited, and it's to be seen that the waste is collected as a commingled collection, so all the kinds of waste are collected together. The cars bring it to the landfills, and the people on the landfills waiting for the cars in order to pick the best valuables for the recycling center for selling in the recycling centers. So the valuables are plastics, or metals, and so on. And on the next pictures, we see how waste management look like in other areas, like in Ust-Bagazin. It's the Baikal Lake area, and we see here a landfill where the waste is is burned on site, and with a hard impact on the environment and on the climate. And on the right-hand side, we see a landfill, the landfill of Accra, the biggest landfill of electronic waste in Africa. And the electronic waste comes from all over the world, also from Germany and from the industrialized countries. And the people living or acting on these landfills, they pick out the metals and separate it for selling to the recycling companies. So it's a social, an economic, and a technical challenge to change these things. The international challenge means that the waste management and circular economy are in the tension field of health, because these landfills influence the dumps regarding the leachate production, and this leachate can reach the groundwater, and we have some impact on the water supply system. Then we have to consider that there is a wealth development regarding the consumption. So more income leads to another behavior in the consumption. Then we have the environmental protection within the technical possibilities, and the tourism development. Tourism is developing in countries where the waste management system is not so successful, like in maybe Germany or other countries. And so the tourism depends on a good waste management system, because the people like to go to countries where the waste management system is working. Then we have to consider the availability of resources and the security of supply for the industry and in the global world. For the climate protection, we have the clean development mechanisms for financing, and regarding the governance and political system, we have intentional waste management systems. In this tension field, we have to work when we think in circular economy solutions. What looks waste management or circular economy in Europe like? We see the countries, the European countries, and their handling with the waste. And we see that the poorer countries like Romania, Bulgaria, Latvia, Malta, most of the waste is landfilled. They only have a small recycling sector, and incinerations plants are not to be found in the countries with a low income per inhabitant. And in the richer country, we go to Austria, to Belgium, Germany, Netherlands, and so on. We see that nearly no waste is landfilled. The blue columns are the landfilling. And there is a good recycling system. The magenta colors is a good recycling system. And we have incinerations planned for the incineration of non-recyclable waste. The incineration plants produce some energy in Germany that are approximately 2% of the energy demand we have. For the organic waste, in a lot of countries, composting or digestion of these organics are established. When we have a look to the waste amounts, we see that poorer countries have a lower waste amount with 250 kilogram per inhabitant in year, in Romania, for instance. And in richer countries with a higher GDP, we see that the waste amount per inhabitant is between 600 and 750 kilograms per inhabitant and year. Circular economy in Germany is a success story of the last 30 years. So when we see that we had an economic growth of 36% from 1992 to 2019, we realized that the waste volume remained almost constant. Let's have a look to the picture. In 1990, approximately 39 million tons of waste were produced by the households, and 87% of this waste went to a mixed waste bin, and only 13% went to the recycling bins, like the bio-waste bin, the glass bin, and the paper bin. And when we have a look to the year 2016, we see that the waste volume remained nearly the same. So it's approximately 44 million tons of waste in this year. And but we established a good separate collection system so that we collect separately about 62% of this municipal solid waste separately as bio-waste, as light packaging, as glass, or as paper. And only 38% go to the mixed waste bin as a residual waste. So the total amount of residual waste that cannot be recycled decreased from 34 million tons to 16 million tons per year. And the recyclables increased in this time very much. And the recycling of municipal waste increased to 65% since these years. But not only in the municipalities, also the industry have shouldered the voluntary commitment for conserving resources and avoiding wastes, reinforced by obligations for returning and recovering recyclables, such as glass, packaging material, metals, and so on. As for end-of-life vehicles, batteries, and electronic waste which contain toxic substances are obligated for the states to separately collect it and to recover. And so we established this, however, successful system. What we see here, what is the state of the art in Germany? In Germany, all waste streams are registered, and in a lot of countries, all these waste streams are registered. A separate collection of recyclable material was established. For instance, packaging waste, the increasing amount of packaging waste is sorted and supplied for recycling. But what about the return to the production cycle? So I will show you two examples. We have a success story with the example paper. Waste paper is the most important raw material for paper production and in the paper value chain. Waste paper usage quote in the paper production is about 75%. In Europe, we have about 72, 73%, and globally we have nearly 60%. But for the production of the different paper products in this wide variety, we use, or the industry uses, more than 600 substances and blends for improving the quality or for special qualities, like sizing agents, retention agents, filling material, and so on. And 60 of these substances, so 10%, fulfill the criteria for the REACH Annex 14 as candidate on the candidates list for substances of very high concern. So that means that no longer all producers in the paper industry sign the European Paper Recycling Council self-engagement for more use of recycling paper or use of waste paper in the paper production. So paper is a success story, of course, because we closed the loop and waste paper is the most important raw material for paper production. But we have problems when we have hazardous material or hazardous additives in the products. So it's not good for the recycling. Regarding the plastics, we have a high challenge. Worldwide, only 2% of the recycled plastics are used as secondary raw material for new products. And what happens with the plastics? About 40% are littered, either marine or rural. 32% are landfilled, and 14% are incinerated with an energy recovery. 14% are collected for recycling, but only 2% go for closed loop recycling. We have 4% process losses, and 8% go to a cascaded recycling. What we see is with the separate collection of the waste, we can start with a circular economy system, but actually we are in many cases far away from that. Therefore, a circular economy is the second step. The first step is a good waste management system. What is the role of the engineers? I highlighted at the beginning. So we see these two cycles. It's a technical cycle and a biological cycle. And for both cycles, the engineer can be responsible for the development of technical innovations, for the planning of logistic chains, regionally, worldwide logistic change. But the most important thing is to improve the product design as design for recycle. When we have a look to the technical cycle, we see that after collection, the product can be maintained, or can be go for reuse to a service provider, or can be recycled to the parts manufacturer and brought back to the cycling system. In the biological cycle, we see a very close cascade use and cascaded cycle of the biological waste or the biological materials, and we can have the biochemical conversion regarding the production for regarding the use for the parts manufacturer, and so close the loop in the biological cycle. A challenge is in demand-oriented production and consumption pattern, an efficiency increase through cascade utilization of the process, and the engineer is a consultant for business and governance, because we provide the technical solutions, or we develop the technical solutions. What are the challenges facing the circular economy worldwide? We see our waste hierarchy, where prevention is the most important or the most favored option, and the least favored option is the disposal. So circular economy is a promising paradigm for a sustainable world. A changed trade situation provides an opportunity for a global recycling sector to further close national and global cycles. So the waste collection already is established in many parts of the world. It can be improved, but it's, however, established in many parts. In future, the awareness of the production site for the use of secondary raw materials as substitutes for primary raw materials must be increased. That is very important for closing the loop and establishing a good circular economy system. Only good recycled material can be circulated meaningfully. We have to consider that the social and economic development always goes much faster than sustainable ecological development. So these different challenges must be addressed with a pragmatic and innovative techniques, and all the stakeholders are responsible for that, and all the stakeholders have to work together in order to fulfill the idea, or to make the idea of circular economy real. With these words, I want to thank you for your attention. I wish you a nice and interesting conference, interacting all these stakeholders we need for establishing a good circular economy in a sustainable society. Thanks.